All right. Oh no, the video ended. Dang it. Oh, hey, how's
We
it
have
going?
7 views.
7 views. I know. Look at this. And a
And
like.
Andy has been watching it 7 times.
Exactly.
What up, Andy?
Uh,
Hey, you.
Okay.
oh, did
That's good.
I join? Cool. Hi, welcome.
What's up? So I'm like, I'd say probably 60% asleep right now, but I just wanted to come and just sort of hang out and see if I can absorb some information. So
Nice.
I'm going to be a
Nice.
bit unobtrusive this meeting, I think.
That's totally fine.
A long hackathon.
Yeah,
Oh.
how was it? Do we get a little quick
It was sweet. What'd you say?
do we get a quick overview or what is the
Oh, yeah, for sure. I can show you guys a demo. I assumed you guys, well, like we're recording right now, so I'll show you later. But there was 3 really cool projects. I was working on DApp Hub. Dan Finlay made a little smart contract system so that you can use your DevCon 2 token to vote on EAPs. And then the proposal for the EAP is actually a unit test suite. So you actually vote on a unit test suite, and then we're going to make like a compatibility table for all of the different clients that implement each unit test suite.
Is an EAP the same thing as an EIP?
Yeah.
I am so mad I didn't
Cool.
claim my DevCon 2 token. That's so dumb.
Round 2 will be like a web of trust built on the DevCon 2 tokens, so you can get in then.
Okay, damn it.
And then the third one was Aaron. Aaron from MetaMask is now reading the blockchain state off of IPFS instead of doing RPC calls to Infura. So Infura just publishes the block to IPFS, and then all the MetaMask clients like peer it to each other. It's really sweet, and so it's like so much more scalable. Like, holy crap, it's gonna be sweet. That's my favorite. I'm so excited.
Wow.
Nice.
Yeah, and so then for DAppHub, what Ryan Casey made was an ETH-PM browser. So basically like NPM, but for ETH-PM. And so it's like a really cool like browser thing, and then you can see all the code and stuff like that.
Nice.
Yeah.
Cool.
Anyway,
Awesome.
I'm gonna fix myself a bowl of breakfast. You guys just keep going on.
Awesome.
It was a nice save. Nice save, Andy.
All right. So let's dive into some game theory.
Let us.
Okay. Oh, I forgot to make an overleaf. Let me go to the dev study. What question do you guys want to do first while I go onto this, sign into this website?
Very good question.
Yeah.
Should we do a different document or continue editing the same document?
I'm fine with continuing.
Okay. Okay, that makes it.
Should we like solve some games? Like what feels like a pretty traditional exercise is just given a matrix, find the value of it, find the strategies. Or do you feel like we have done that enough already?
Oh, you're saying
I'm
just
talking like 211, 210 maybe.
Oh yeah. I mean, I think 211 is super good. We started going over 211 last time. I don't remember. I think we finished going over 211, but we hadn't really finished reading the chapter. At least not everybody. Or did we even finish 211? I don't know.
I don't think we did.
Oh, we didn't. Okay, then we didn't
I
start.
don't think we did it at all.
Okay, whoops, that was my imagination.
Okay,
Okay, yeah.
We did a similar one, I
Yeah, I
guess.
think so.
Yeah, 2.11 then. Let's definitely do 2.11. And I shared
All of them?
the first one is pretty, I mean, part A is pretty simple in terms of just like knowing how to solve for, V minus and V plus, and then setting them equal, and realizing that it's going to be a pure strategy. But B is, we can just do B. I mean, that's the only one I did, to be honest with you.
So, but B should be a simple plug and play with the formulas, right?
Yes, exactly.
Yep.
Yeah.
Jack, you have in the past had a sweet dual.
I can fix that, yeah.
That'd be awesome.
It's been pretty remarkable.
Yeah, I'm like, I go back and watch the videos just to like check out the pixel perfect organization.
Wow, pixel perfect. Was that an expression? That is
Yeah.
I
I
heard it.
use it all the time.
nice.
I think maybe it's like a front end developers thing or something.
Yeah, I mean, I'm definitely gonna start using it every time now.
It's
Like in context where it doesn't make sense. Like if maybe somebody is singing like pitch perfect, you're like pixel perfect.
Okay, I need to close some applications.
Andy has that cereal or other delicious.
I was being for real. Really just cereal. Yeah, just honey bunches of oats. If anybody is looking for inspiration.
Are we making this a cooking channel as well?
Yeah, I think that's the next
feel like
iteration.
Since day one.
Oh man.
By the way, speaking of me being asleep right now and being delirious, do you guys all like this time to meet up? Is it too late for you, Martin?
No, it's not too late for me. I mean, or it's not late for me in the sense that I need to be sleeping or that I can sleep at this hour.
Mm-hmm.
But it's like sleep in the sense that maybe I want to do other things than have a game theory meeting.
It makes sense, yeah. Like your desire to do it late at night and my desire to do it early in the morning, I think are similar.
Cool.
What about like an hour in the past? Like, what would it be like? 7:30 or 8?
Yeah, 7:30.
This one started at 9:30 Central European, right?
Yeah,
Yes.
this
So,
was nice, I
Like
think.
8:30
I mean,
Central European.
usually we're doing 7:30, and that's fine by me.
I know, yeah. That's like a bit early for me.
Okay.
What do you think about 8:30?
Yeah, I mean that's fine.
Yeah, I can do that.
Okay,
Yeah.
that's works better for me because I have a meeting at like 8, and it usually runs pretty long because it's like maker, and it's the only time that they talk to each other.
Mm-hmm.
And I just want like some time to like basically prepare between this meeting and that meeting.
Yeah, sure. Yeah, 8:30 it is then.
Cool.
It's official. By the way, nice background. That was a cool background.
Thanks. It's actually stuck with the OS X or Mac OS as it's called.
Really? Wow.
Good for
Mac
you.
OS is what it's called also? It's not called OS X anymore?
No, they switched the name like
What?
6 months or a year ago. I have gotten used to it just now as well.
Mac OS.
Yeah, as in the good old days before they hit version 10.
Wow. But are there still version 10 stuff? Is that still called OS X?
I don't remember if they switched after, like when they went up to 11, when they started calling it Mac OS, or if they are still on 10.
I have OS X.
OX, nice.
I have the OSX.
So I'm gonna start writing up at least the section stuff.
Do you guys have MATLAB, or has anybody been coding
Ooh, that
in
would be cool.
the stuff for this?
No.
I haven't, but I would love to if you're.
I mean, we like for solving this exercise, it seems like it would take as long of a time to write the formula down as it would to code the program that computes.
Yeah,
Almost.
let's do it. That sounds actually very correct. Yeah, that's what I noticed. A lot of this section is essentially just, I mean, we're just kind of learning how to code this up, and most of it is just cookbook stuff that you can use to then code your stuff up. Because I mean, otherwise there's no point. Like for most of these questions, I said use calculator. By that I mean, write program.
The computer, yeah.
Yeah. Oops, sorry about those clicks.
So does anyone have like Mathematica or MATLAB or whatever?
I have MATLAB, but I mean, there's nothing special about MATLAB really. You can do it in Python or Haskell.
Very true.
We mentioned before using Python for something.
Mm-hmm.
Yeah, we did.
Do you want to go through with that, or?
Sure. I don't know it, but from what I've seen of it, it seems very manageable.
Yeah, it's super simple.
Maybe I would like to keep it in Haskell.
Oh, let's do Haskell.
Okay, sure. I'm up for that.
Oh wait, Andy, you should totally weigh in on this because I'm.
I don't care. Go ahead, do an Haskell.
I mean, it's probably the language that I know best, so
Yeah.
Absolutely.
Okay, let's do Haskell. I'm learning that, so.
Good. Anyway, maybe that can be left as an exercise to the reader to code the solution that we're going to do right now in Haskell.
Sure. Sounds good.
So if we're solving the game B, and let's say that we have found that V minus, let's see, we have 5, there we have 5, and there we have 5. So it's going to be 5. And down here we have, nothing. Everything disappeared. So we maximize when we fill out the matrix and write the max mins in an extra column like this. Do we always maximize in the rows and then take the minima of that extra column, or do we do the other way around?
What's the question?
Finding V minus and V plus.
Mm-hmm. You minimize over the columns and then maximize that to find V minus and reverse for V plus.
Nice. So I'm gonna draw here. So I minimize here, I get 1, 3, and 2. And so then we have 3 as our V minus.
No, sorry, I was wrong. You minimize over the columns, not the rows.
Okay.
Yeah.
There's a 50% chance that you do it right every time.
Why do you remember rules anyway?
Did I say it wrong again?
No, you're right. You're right.
Yeah, I mean, Martin's doing the right,
what's-
but I think I might have said the other way. Either way, this is right, if this is with V minus.
That's a 5 for anybody who's wondering.
Yeah, I can see
Oh,
This is also a 5. So V plus is going to be 5. Cool, you guys. So they're different, and you know what that means? Ding, 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 ding. We're gonna have a mixed strategy.
Yes.
Yeah.
No pure.
So we should definitely include that check in our program.
Yeah, for sure. And so now, V is going to be given by the following formula. Like there's an A here somewhere.
Oh yeah, I need to get the formula.
Yep. Okay.
And this is the formula
It's given
for
by 1. This is the formula for invertible matrices.
Okay. Yeah.
Oh, that's, I don't know why I wrote a 3 there. That's really doesn't make sense. Should be a 1. It's the matrix inverse. I don't know what matrix to the power of -3 is. There we go. Now, does anybody want to invert this matrix? Not really, but I mean, it's what we have there. That's the answer. And so X is given by, I think you just put JNA here. Am I correct?
Oh, I actually wrote down the inverted matrix, but
You wrote it with a prime or whatever. Or what did you write?
I don't know. I'm trying to figure that out. I don't know.
It's actually correct what I wrote. That's pretty amazing, I think. Oh, no, just this should be also inverse.
The formula for V is on what page?
69.
Okay. Here we are.
Yeah, and the only thing that differs in the formula for X and the formula for Y is that you shift the order of the matrix multiplication.
Yeah, and the and X and Y represent the strategies, optimal strategies. Is that correct?
Correct.
Weightings,
Yeah.
or I should say.
Sorry?
The weight. I mean the weights. The strategies
Sure.
weighting.
Probability.
Yeah,
Space.
exactly. For each possible choice.
Yeah, exactly.
And the reason why
Right.
you use Y sorry.
Mm-hmm.
I was just going to say the
I
reason
use
why
Y transpose because
is because the
connection.
is Martin. I'm getting you like going in and out. Is that my connection?
No, I
it's
think
not
I lost
mine.
you guys.
Yep.
Okay.
So we want X and Y to be vectors or rows of entries. Yep.
Yeah, and because Y is the column player, then you need to use the transform.
Vector, and we want both of them to be row vectors. So it's just a little technicality. Cool.
And what is J in this?
J is the identity vector.
So it's the one with just matrices, no, with just once.
Yeah, exactly. Yeah, that took me. I remember looking at that and getting confused initially.
Hey,
Cool.
Hey.
Hey.
I don't know what happened. My
You
Zoom
disappeared.
just died. Yeah, thanks. But J is the vector consisting of ones in every entry. So it's a n times 1 matrix consisting only of ones.
Cool. So should we? So this is all set up for potentially solving, right? No, I mean there's a. This is how we would solve it. Solve an invertible matrix. So later in this chapter, they give the like a general form solution for how to solve games using just like minimizing linear programming. But in the case of invertible matrices, this is like an even easier way, as long as it satisfies those qualities.
Mm-hmm.
Because we can do some math. Okay, cool.
And specifically the qualities that it has to satisfy, besides it having an inverse, is that the value is different from 0, and that the product Jn A inverse Jn transposed should also be different from 0. Because otherwise we would be dividing by 0, obviously. And that's problematic in this setting.
You like theoretical mathematician.
Problematic in most settings.
In most settings, yeah, for sure. But you can make sense of it in some context.
Okay.
Like if you have the Riemann sphere.
No idea.
It's essentially the complex plane with an added point.
Okay, right.
Which is like the point of infinity.
Point of what?
Infinity.
Okay. Where on the plane is that?
It's not on the plane, it's on the sphere. So like the way to get from the sphere to the plane is that you imagine that you have this sphere sitting like at the origin, and then from the North Pole you project out to points on the plane, and the point at which that line crosses the sphere is the corresponding point on the sphere.
Right.
And so if you go to infinity in every direction, you're gonna stay on the North Pole, or like you're gonna approach the North Pole as you go towards infinity in any direction.
Yeah. Cool.
So Jack, I've heard a lot about your programming abilities in Haskell. So I'm excited to see you program this on the spot.
Okay. I could do it. I'm probably a bit stoned, but sure.
Did you just pack a big bowl of cereal?
No. Use the volcano.
Andy always breaking things.
Such a radical.
I had too much cereal.
So we should probably use some kind of linear algebra library, but I don't know any, and it seems boring to sit around and learn. So let's just use lists. And yeah, I guess. Okay, as long as we just make sure that we input things of the correct length and stuff, it should be fine.
Martin, while he types.
Yeah. You gotta
So
give
let
me
me.
another impossible task.
Well, this one's not impossible. Don't worry. Dividing by 0, I thought it was impossible, but never mind. I don't know what's possible these days. So, no, this is more about Haskell syntax. So when I said
Okay.
I'm learning Haskell, I mean I spent about 20 minutes in a cab ride.
Mm.
So the double bracket int,
Mm-hmm.
2 lists.
2 lists
Or-
of
or
type
no.
int.
No, like
List.
a list and a list.
List of lists.
Yeah. That's I made that conversion.
In other ways, a matrix.
Yeah, matrix, exactly. Okay.
And the output is just a list, so that's going to be a vector.
I see. Okay, very good.
And in the case of V, it's just an int, so it's just a number.
I see. And the one thing we're kind of changing is that we don't there's no transform. We don't have to do the kind of Y transform.
No, I guess not. Yeah, we just assume that all of them are on the right, required direction.
Yeah, that makes sense.
Yeah.
Oh, right. We might get to floating point numbers since we're taking fractions and stuff when we do the inversion. So we can't do integer division.
Yeah, but I mean, are you gonna code up matrix inversion?
I
think that's gonna be annoying.
Yeah, I agree. So, since I don't know any linear algebra libraries, maybe we shouldn't do this with the video time.
Yeah, I think so too. This is the only advantage of using
MATLAB.
something like MATLAB because it's made
exactly.
for linear algebra and matrix handling.
I mean, you do have that in other languages as well, but
Yeah.
not
we
at the core.
Leave it up to the viewer to code it up in Haskell. We've got 7 viewers. At least one of them is going to code it in Haskell.
Yeah, Andy, did you watch 7 times?
Yeah.
As much as I love you guys, I got bored.
After they. So we want to do MATLAB, or do we want to go to another problem?
I don't have MATLAB installed. I think.
Okay, that's a reasonable blocker.
Wait, actually, I do.
The twists and turns of this video are so compelling. I'm shocked we don't double our viewership. If we don't double our viewership, this next. I have a question about the next chapter, next section around symmetry. He uses this, or she, the author, uses on page 81. It's they write, which means equality all the way. And essentially that's in reference to these greater than or equals doing let's see, which means equality all the way, right? Why does that mean equality all the way? I wasn't totally sure.
Very good question. I actually haven't read this. I'm checking it out now.
like, I guess you can, I mean, it looks like it's equal, right? Just kind of watching it, how it goes x2, x3, x3, x1, x1, x2, and kind of showing that. And if you like chain it, it kind of makes sense that it would be equality all the way. But I wasn't able to, like, I didn't just.
Oh yeah, right. So this essentially go in a circle. So since we know that x2 is larger than x3 divided by 0.12, we know that this x2 is gonna be like the same, and that's larger than this, and then that's the same as that. Those two, so that's larger. So it goes in a circle, and since all of the inequalities are pointing in the same direction in the circle, we know that none of them can be big, actually be bigger than each other, because then some other inequality would be violated. So they have to be equal in the circle.
That's super cool. Okay. Yeah, I didn't know. I didn't think of, like, that's like the circle thing is very cool. But yeah, so basically what that means is, like, earlier in this section, it basically states that because of these rules of symmetry, we're able to figure out that the value has to be greater than or equal to 0. And I forget exactly why it was the case. But then we got these three equations right above it, where it says like x, x star 1, and it does it all for all three. So I guess what you're supposed to do if you do have symmetry is reduce those and find whether or not you can get inequality. I don't know when it wouldn't be equal, but I assume that there must be times where it's not. And then you can, of course, solve if they are all equal. You can solve for each one very easily.
Yeah.
Yeah. So that's basically the, equality section, or symmetry section, excuse me.
Right. Cool.
Martin, what's up?
My internet doesn't work. I don't know why. It has.
I thought you were supposed to have really good internet in. Wait, you're in Sweden right now, no?
Yeah.
What are you doing? Like,
I don't know. It hasn't happened before. Maybe
you don't have to excuse yourself.
Well, I'm not excusing myself. I'm explaining myself. But thanks. I don't know what's happening. Yeah, that's all I can tell you. What are you guys doing?
Okay, well, we can if your internet's not working, I do like the idea of solving it with like MATLAB or some programming language, because then we can just like input it every time, because a lot of this is pointing to that, which is really like, I really like that about this textbook actually. But we just went over, I marked 2.25 as a problem that that is solvable using symmetry. Like that's the for that section. But we kind of, I don't know, I just don't think it's all that important. There's only 3 questions on it, and it just doesn't seem like this whole symmetry method is that useful, other than just like, oh, we can do this cool thing if you're solving these games by hand, which we shouldn't be doing anyway. So maybe what makes more sense is talk about 2.27, which is after the whole matrix games and linear programming section, and just like make sure that the two, there were 2 methods that are essentially analogous for solving matrix games using linear algebra. And the first one, you apply a transformation, and then you formulate it in a certain way, and then you just do like a bunch of math to kind of find the what's it called, optimal strategies. And then the method 2 is just you straight up take the values for each element in the matrix, and you plug it in, and it's like messy math, but it comes out that you can solve it. Did you guys look over this section, and like, do you understand those 2 methods more deeply than my surface level?
No, and hence no.
Yeah, unfortunately not. I haven't really been able to find the time to look through.
Well, it should be pretty easy. So let me find, at least we can look at the stupid formulation. Because it's really nice to finally just be able to copy and paste things and get an answer. Let's see. Yeah, this section was super dense, but mostly just explaining.
Do you have a page number where the procedure is described? Summarize this as a linear program. Minimize set I, P. Okay. Subject to A.
Yeah, so I think, I don't know, what are you looking at right now? 86 has, yeah, 86 has I think the first formulation, or, oh, I see, never mind, 84. Check out 84. I think that's, I highlighted something on the page recently.
To get the value, it's a pretty straightforward thing.
Yeah, it was, I mean, it was like a lot of cookbook steps.
Mm-hmm.
So the two versions, one with the transform and one without the transform, the transform just makes it easier to solve by hand, which I kind of, I don't know, it's hard for me to setting up the linear program method one, that's like right on 83, where it just kind of goes over this method. But I don't know. Do you think, I mean, how interesting / important do you think it is to understand exactly how the thing is implemented, other than like it can be implemented in such and such a way?
I think like understanding the procedure would be pretty important. Like, I mean, it's not very different from what we have read before, you know, where they want to maximize their reward. I mean, of course, that's what they always do. And so it's just like different methods in which this can be done.
Yeah, I mean, I would like to understand it on a like kind of high level, but I don't really mind the details.
Yeah,
Right.
that's
I mean, in a sense, it's pretty straightforward that you have a system of inequalities.
Yeah.
And then you minimize with respect to some constraints.
Yeah. I mean, I've done linear programming separately and integer linear programming as well. But we actually used it to prove the min-max thingy that we talked about before. But I guess it's the most straightforward formulation. Yeah, more or less.
Cool.
So, and I'm actually not very familiar with linear programming. So what is like, is there something super special about linear programming outside of its inefficient way to solve min-max problems?
I mean, it's essentially these kinds of problems, and you can formulate like quite many like common algorithmic problems as linear programs if you just do some clever modeling. And then once you have something on the form of a linear program, there are efficient algorithms to solve it. But it's still like only a subset of problems that can actually be solved in this way. But it's like for them, it's efficient.
Yeah, cool. Sounds good. So, yeah, the thing with the box around it, I believe. Cool.
Yeah, I mean, I've done a lot of matrix programming a while back ago, and I don't find it super interesting, to be honest. But I guess we should know what minimization problems you're solving, the general strategy without too much details.
Yeah, that's a good
and
good idea.
And then like implementing it is fun if you have a language that allows you to do it as easy as it can be done.
So maybe let's just check out method 2, because method 2 is like, this is the minimizing problem. And then just plug it in. So that's method 1 is more like, let's put it in a nice format. Method 2 is faster. Here we go, right here. Okay, so player 1 wants to choose a mixed strategy X. So it maximizes V. Subject to the constraints. X star is the strategy / waiting for the choices. AJ is
With all, no, wait. Oh, right. It's the row 1 of matrix A, or row J.
Row J,
sorry.
yeah.
row J of matrix A. Okay, and matrix A is the game matrix, right?
Mm-hmm.
Yeah.
Yeah. Okay, and then equals. Oh, and then it's the expected value thing. See, this is what we were doing before with the symmetric stuff.
Exactly.
And has to be greater than V. And so that's why it's like a good introduction to the actual program. So you then, and I forget, sorry.
So we're saying that we want to maximize V, and it has to satisfy this constraint.
Yeah, cool. And I presume, and there's another constraint below. Is that a different formulation of the thing above, or I think it's?
No, it's just saying that our percentages should add up to 1.
Okay. Yeah.
So
Cool.
2 constraints.
Yeah. So that the player 1 should pick like some strategy with probably that one.
Yeah. Okay. So this is pretty simple. The like maximize V makes perfect sense. Sum of all your strategies equals 1 makes perfect sense. The only thing is like the expected value of X has to be greater than or equal to V, but that actually does make sense, because if it was negative, I forget exactly why that was. Seemed to, oh well, that's the one thing that I think I don't fully understand, is that.
So I think that if you have chosen an X star in such a way that there is an entry in the row that will end up giving you a lower
negative
value,
yeah.
then that won't be the optimal strategy.
Yeah, you wouldn't include it. That makes perfect sense. Does that make sense to other people? Wouldn't that be, it would be, you're giving it a percentage, right? You're giving it a weight.
Yeah, you're giving weights to all of the rows, and if there is a row
That you give
that-
negative weight.
no,
Am I crazy?
none of them can get negative weight. They can be
That's why
at
we have
least
that.
0.
Yeah. Oh, okay. I see. Yeah.
So all of your probabilities are going to be between 0 and 1, and they all have to add up to 1. But if you give too much weight to a matrix, and like leave room for a V to well, how should I say this? Like I'm looking mostly at the second line of this equation. So x star times aj, and we look at how much weight we're giving to every column, and if there is a if we distribute our weights in such a way that yeah, I mean, I can't really formulate it in a nice way, I think.
Yeah, I think everything makes sense minus the intuition behind this, but I know that was stated, I think, in the symmetry section. So we can always go back and check it out. But that's like as much kind of depth that I thought was useful from this section in the textbook, just because it's essentially like, here's the formulation. It uses stuff that we've built up before, and especially in the, like, you know, outside of these sections. And I don't know, everything kind of makes sense. Maybe I'm a cop out, but
I think correctly.
Sorry?
We know that for the, like, if player 2 chooses Y star, i.e. its best strategy, then the value of the game is going to be V. And we also know that if player 2 is going to play something worse than the Y star, then the value of the game is not the value of the game, but the result is going to be higher than V, since player 1 will profit off of player 2's like suboptimal choice. So this is always going to be larger than V.
Nice. That was awesome.
Yeah, and so I think we can think of the different values of x star aj as we're trying to make them as large as possible for every possible column. And so if there's one column that sticks out in a way that, you know, we give it not enough weight with respect to, or sorry, if there's one row that sticks out, we give one row too much weight, then there's going to be an entry in that row that player 2 can utilize in order to get a V that is smaller than what we have optimized for.
Cool. I do want to, at some point, I should like either code this up, so I can make sure that I fully understand that it'll work. But I have to say, I'm very excited to get on to chapter 3.
Yeah. So maybe let's move on to the next section.
This is the last section. Congratulations. We finished chapter 2.
Wow. Okay, then let's do the last exercise of this section.
So well, I don't know the last exercise. Let's see what it is. Oh yeah, this had such cool things. I forgot. I was going to mention that.
What?
Just these questions at the end are really cool. Like we should totally these are actually really cool questions and we should give them more time because
Like
they're like
246?
word questions.
Yeah.
Oh,
we should do 245. It's Corleone. Is this from The Godfather? Okay, so I'm gonna read 245.
dope.
Out loud.
I don't know if you want me to.
The
It's
evil
not-
Don Barzini has imprisoned Tessio and his 3 underlings in the Corleone family.
Total value 4.
Wow, so okay, cool. Let's write this up. So let's make Sonny the role player. And Don Barzini. Don Bar. Column player. So, okay, in the first case, Don Corleone goes out to save the Corleone family, or Sonny. Sorry, Sonny goes out to save Corleone, and if Don Barzini also does it, then they have an even chance of arriving first. So I guess it's going to be.
Annotate. Maybe someone else can do that.
Yeah, I don't have an internet connection, so I can't.
Is that how you're talking to us?
Yeah, through 3G.
I feel like there's a bunch of questions like this, and I feel like they're the most, or they're very helpful for getting into the mindset of formulating these problems.
Oh yeah, definitely.
Yeah, I'm wondering about one sentence here. If they set out to the same place, Barzini has an even chance of arriving first, in which case Sonny returns without rescuing anybody. Should we interpret that as that if they choose the same option, it's 50-50?
Yeah, I think so.
Yeah.
Okay. So like in that case, the payoff is 2. And then we have 1.5, which is annoying, but okay. Can't they have a larger family? Like a family which is evenly divisible by 2?
Right.
Anyway, so my matrix looks like 2, 4, 3, 1.5. Does that look The same for you guys?
I just started because I finally bit the bullet and realized that I couldn't annotate the screen.
Oh.
Say the what was your matrix?
Going from left to right, up and down, it's 2, 4, 3, 1.5.
Yeah.
Nice.
Yeah, same.
Cool. I think my internet is back just for a while. So first of all, is there a pure strategy of it?
V minus.
Nope, none.
Yep.
All right. What would you do if you were Sonny?
Like, stop being a mafia guy.
Yeah, I do math.
Call the cops.
Gonna rat out some those fucking weasel, man.
I would probably plug this into the equations that we have here on the screen.
Exactly. There we go.
Like, or we could start by checking whether the matrix is invertible or not, or we could plug it into the like algorithms.
Does it look invertible?
Yeah, it does.
What makes it look invertible? Okay, no, I don't want to distract you from
The
solving.
fact that its determinant is non-zero.
I see. Okay.
So the determinant, if my calculations are correct, is -9. So 2 times 1.5 minus 4 times 3.
Yeah, same here.
3 minus 12. So we're going to have a factor of 1 divided by -9 to get the inverse. And then what do we do? Flip these, I think. And then we like flip those and make them negative or something.
They don't really give us nice numbers to work with.
Yeah, these are horrible.
Yeah, we should just multiply it by 2.
To get rid of the 1.5.
Yeah.
Yeah.
Okay.
So now they feel twice as strongly about whatever they choose to do.
Yeah.
More feelings. Great.
They love a family member with 2, as if they were 2 people. Yeah, so my matrix, the inverse, for me, without multiplying it by 2, is glorious minus 1.5 divided by 9, and then 4 divided by 9, and then 3 divided by 9, and minus 2 divided by 9.
Yeah, same here.
Nice. Okay. And so Sonny's strategy is J n, no, it's A inverse J n divided by Jn A inverse Jn transposed.
I get to 7/18 for V.
Yeah.
Does that match with the others?
Well, that's 1 divided by V.
Oh, right. Yeah, sorry.
Mm.
Yeah, exactly. And then so the probabilities that I get are 5/7 and 2/7. But I did that very quickly in my head, so I'm not sure. I'm right.
And 2 to what?
2/7.
And 2/7. And this is for x, right?
Yeah.
We did it. Let me actually verify that's correct. 5/7 and 2/7. You were right. That's why. Well,
Nice.
that's what they called Y, but that's basically it. There we go. Congratulations.
That's why.
Yeah, that's why. It's. I mean, according to them.
Who did they pick to be who?
Oh yeah, exactly. They picked Sunny as their like role player. Is that what you call it? Sunny / Barzini.
Wait, which one? Sonny is one player and Barzini is the other.
Oh yeah, which I think I mean I believe the main player that they gave points for was Sunny.
Cool. Then I screwed up slightly because that was supposed to be my X. So the X is what I just gave you, but maybe I did Jn A inverse.
That's okay. We can. I'm satisfied that we were able to pretty much solve it. It's pretty awesome. But I think so. My personal preference is I would like to go over a couple more of these problems next week, just because they're very cool. Like they have, nice word problems. And I'm also down to like dip my toes into chapter 3. Does that sound good? What do you think we should do?
I think that's a good strategy.
Yeah, I think so too.
Sweet. And Andy,
Yeah.
what are your thoughts on like, do you think that like I want you to be there,
Yeah, for sure. So basically, like, I've been like scrambling with other stuff for the last 2 weeks. But this week I'm just gonna be catching up with all the things I've been ignoring. This is one of them. So I'm just gonna be like spending time to, like I said, get caught up. I might hit you up, Carl, if I like.
Yeah, I'm happy to go over stuff with you.
That's kind of what I was planning. But I'm just gonna rewatch all the videos again, and just sort of like get up to speed, because I'm still sort of stuck in thinking about it all in terms of the old book. So I just need to, like, I don't know.
There are only a couple like really important concepts, and I think now that I have a general idea, I can we can go through real quick.
Cool. Yeah.
Sounds
Right.
good.
Yeah, I'm still emotionally invested. I'm just way behind this far.
That's good.
Cool.
Wonderful.
Yeah, I feel like the problems aren't super stimulating in this section. I mean, they're all pretty doing the same thing. That is not to say that I know immediately how to solve all of them. I think I need to look over certain things when it comes to like how you can reduce the problem with respect to its symmetry, and maybe remind myself of how to do it in the general case where the matrix is not invertible.
I think
it feels like as long as you have a matrix, then the procedure is pretty clear.
Yeah, I agree completely. I think the only thing that's interesting is just the last section has a couple word problems, which I would love to kind of get the matrices for and then not solve them because they're just boring at this point, right? I think in terms of mixed strategy, Nash equilibrium, we know that every game that has that, with a mixed strategy has a Nash equilibrium, and we know that we can solve it with relative efficiency, right? So I think those are the key things that we need to know, and we do know, and now we can move on to other stuff, which I'm looking forward to, like more conceptually stimulating stuff, because I feel like I've been on the mixed strategy Nash equilibrium for like my whole life.
That's true. That's true.
I agree.
Yeah, and especially like if we just code up a program that can, given any matrix, find x and y, then it feels like we never need to do anything like that again.
Well,
Exactly.
it looks like chapter 3 is 2-person non-zero sum games. Anyway, we'll figure it all out. But I want cooperative games. Chapter 6, please. Okay. Anyway, we'll get there. We'll get there. Cool. Well, thank you guys for coming. I have to run.
Yeah. See you.
Sweet.
See you next week at 8:30 p.m. CET.
Sounds good.
Awesome.
Right.
Love.
Bye.
Bye.
Bye.